In our last section, we talked about angle measures and how they related to the angles from the center of the circle. And now we're going to talk about a couple more angle measures inside of a circle from different locations. So our first one, we're going to review the angle measure at the center of a circle. So our first one is where our vertex of our angle is at the center of a circle. And this is also referred to as central angle sometimes. Remember, vertex, that word vertex means it's the point where our angle comes together. Right here, this point right here, I'll make it a different color. This red point is our vertex of the angle. So if our vertex, that point, is right in the center of our circle, right here, then we know our formula, our angle our symbol for angle right here is going to equal our arc. So if we look at the example here, if we had our center right in the middle, we had point A right here and point B right here. If we knew our arc was 105 degrees and we wanted to find this angle right here, our angle equals our arc when it's in the center. So that means we call this angle 1. Angle 1 equals 105 degrees. Our next case is when our vertex is on the circle itself. And these are referred to as inscribed angles. So that means our vertex would be right here. And our center is still here, but our vertex is where that X is. And our formula for this is that our angle is going to equal our arc divided by 2. So you can write that in symbols or in words. It's going to mean the same thing. Our angle equals arc divided by 2. So if we look at an example here, we've got 2 examples actually. Our first one, we have a point on the outside. We've got rays going this way and a ray going this way. So this arc right here is 140 degrees. And this is angle 2 right here. We want to figure out what that angle 2 is. We need to take our angle equal to our arc over 2 and solve. So if we have angle 2 equals our arc, which is 140, divided by 2, that means our angle 2 equals 70 degrees. Now if we wanted to do the reverse, if we had this example down here, if this angle right here was 60, and we wanted to find what our arc AB was, we would have to take our angle equals our arc divided by 2. Our angle in this case is 60 equals arc over 2. Multiply both sides by 2. We get 120 equals our arc. run out of space there, but that means this arc right here, AB, is our arc, is 120. Okay? Our next case, if our vertex is inside our circle, but it's not at the center. This is called an interior angle. So an example here would be our vertex of our angle. It would be right there. Now, if we have our formula for this arc, our angle with our vertex inside but not at the center is equal to our arc plus arc over 2. In words, our angle equals arc plus arc over 2. So let's look at an example here. If we have lines looking something like this. If we knew this section was 30, this was 50, and we wanted to find this angle 1 right here. We have our equation. Our angle equals arc plus arc over 2. Now our two arcs in this case are 50 and 30. These two arcs right here are the ones we're talking about. Our angle equals 30 plus 50 over 2. 30 plus 50 gives us 80, divided by 2 is 40. So our angle 1 in this case is 40 degrees. And our last one here, in this case, our vertex is outside our circle. And we call this an exterior angle. So for our vertex of our angle, we're out here somewhere. Formula for this case is similar to above, except we have our angle equals our arc minus arc over 2. Okay, so in this case, if we put our angle something like this, call this angle 1. If we knew this arc right here was 20 and this arc right here was 50, we need to use our formula to figure out what our angle 1 is. So our angle equals arc minus arc over 2. Plug in those numbers. Our big arc is 50. Our smaller arc is 20. And divide that by 2. We're left with angle 1 equals 50 minus 20 is 30. Divided by 2 is 15. Okay, so that's a lot of information, but we are going to use this information to go over a few examples next. Okay, so these are the next 3 examples that we're going to go over at the top of your page, so above that big circle at the bottom. You'll have to pause the video and draw these, make sure you label the given information, and then we're going to go over these examples next. Okay, so this first one, our example at the top, we have our vertex on the edge of our circle. So our equation for a vertex on the edge of a circle is our angle equals our arc divided by 2. Now before we can do our arc divided by 2, we got to figure out what this arc here is. So they give us this piece is 80 and this piece is 60. We want to know what the rest is. Well, we know we have 360 degrees inside for our whole circle, and we take away 80 and we take away 60. We are left with 220. So that means this red piece right here is 220 degrees. Now that we have that piece, we can find our angle because it is our arc, which is 220 divided by 2. And that gives us our angle is equal to 110 degrees. Okay, let's look at number 2 here. If we have our angles, 3 angles here, are inside our circle, but they're not at our center. So my equation for this one is going to be angle equals arc plus arc over 2. So to find my first angle, angle 1 and angle 3, I have my 2 arcs right here. So I can plug those in, and I'm going to get 30 plus 100 over 2, which equals 130 divided by 2 gives me 65. And that is my angle measure for 1 and 3, because if you look at 1 and 3, they are vertical angles. They're right across from each other, so they're going to be equal. And they also have the same arcs for our equation, arc plus arc over 2. Now to find out what angle 2 is, I can do it a few different ways. But the easiest way is if I look at angle 1 and angle 2 here, they make up a straight line. Angle 1 and angle 2. So I know angle 1 plus angle 2 is going to add up and give me 180. So if I start with 180 and I take off angle 1 here, I'm going to take off 65. I'm going to be left with angle 2, which gives me 115. Okay, in our next example, we have, again, our angle is inside our circle, but it's not at the center. So we have our same equation. Angle equals arc plus arc over 2. But we want to figure out what angle 1 is. So if this is our angle 1 right here, we don't have this arc or this arc to figure out what that angle is. But I do have these 2 arcs on the other side. So I could figure out what, let's call this angle 2. I could figure out angle 2, and from there I can figure out angle 1. So let's figure out angle 2 by plugging in our numbers here. We have 120 plus 140 divided by 2 gives me 260 divided by 2 is 130. So that is my angle 2 here. Now if I look, angle 1 and angle 2, they're on a straight line. So I know angle 1 plus angle 2 is going to give me 180 degrees. If I have 180 degrees and I take off that angle 2, I'm left with 50 degrees. And that is my angle 1. For our last example in this section, go ahead and label this information on that big circle on the bottom of your page. Okay, and once you do that, you can continue playing the video. Our first arc that we're looking for here is the measure of arc AX. And remember, that's what that little M stands for. It stands for the measure. So if we have AX, that is this piece of our arc right here. Well, if we know that this piece here is 40, and this whole thing from A to Y is 260, we have 360 in our entire circle. We take away 260 and we take away 40. We are left with 60 degrees for AX. Our next one, ABZ, goes from A to Z right here. ABZ is this piece right here. If we notice, we have this straight line from A to Z going straight through the center. ABZ is half our circle, our semicircle, so right there is 180 degrees. Then we have the measure of angle XAY. XAY, right in here. So that is this angle right here. Well, if we look at our formulas, we know our vertex is on the edge of our circle here. Our formula for a vertex on the edge of our circle is our angle equals our arc over 2. We know our arc is 40 degrees. We can plug that in, and that means our angle equals 20. So XAY is 20 degrees. Then if we are looking for the measure of angle YAZ, which is right here, Y to A to Z, which is this angle right in here, we are going to use our same formula. But in this case, our arc right here is what we need to find first. Well, if we know that this arc over here is 60, we already found that piece, and this one is 40, our 60 plus our 40 plus our YZ here is all going to add up to 180. So if we have 180 and take away that 60 and take away that 40, we're left with 80 degrees. So if our arc is 80 degrees, we can plug in our formula, and we get our angle is 40 degrees. Okay, and our last piece asks for the measure of arc XAZ. So we go from X all the way to A and all the way back down to Z. So we could try to add up all those pieces, or we could take away our XY, and our YZ. So if we know we start with 360 degrees, and we take away 80, and we take away 40, we are left with 240 degrees is our XAZ.